master's in AI and cybersecurity. My main focus is in network security and artificial intelligence, and I'm leveraging the tools and technologies of AI to enhance network security and protect institutions against known signatures attack. So I'll be presenting today on zero trust boot, which is more like a solution to one of the urgent digital threats in Africa at the moment. The presentation will detail the device that poses this attack and also how zero trust boot serves as a solution to this particular problem. We've seen over the years how Africa has grown, and the statistics you are seeing is from statista.com, and the bars you are seeing are in the millions. And we've seen how countries are being segmented and denoting the millions of people that are leveraging the internet in Africa as a whole. And with this huge innovation, we can be certain that it has transformed Africa in a way that it has never been seen before. We're experiencing personal growth. It has impacted us in the government sector, in business sector, in the educational sector, and also in the economic boost. And with all of this, we want to ensure that what we are building is more sustainable. And because of that sustainability, we want to ensure that the foundation that we are building this growth on, it is more protected against known vulnerabilities that are happening across the globe. With this, it is of concern that the device that we are currently using, and I'm sure we are using the device now in this conference center, and we're using it in our homes, in our offices, and also in public places. This particular device poses a lot of risk to the African market, and it is of high intent that we understand this device and understand the risk that it poses. And I name the device the visible threat, which is the router. And I'm sure everyone knows the router. We are using it. It plays a key role in ensuring that it maintains network communication between devices internally and also in the external interface. But with this particular device, it has posed a lot of problems and is more susceptible to attack now than it has ever been in the history of router. The attack surface that router poses is that of its default credential that is being shipped with. And studies have shown that in Africa and in other places, it has never been seen that people usually change their default credentials. We usually leave them by default. And I'm pretty sure that most of us in this room knows the default credentials that most of these routers are shipped with. I'll give one, which is admin. This is by far the most general default credentials being shipped with routers. And there's another one, which is admin password. It is also a known default credentials that have been shipped with routers. And the last one is this, which is admin with no password at all. So with this gives an attacker a dictionary attack surface in which attacker has already known these credentials. So when they want to attack your device, they just put these credentials in a dictionary format and just map it and create a botnet against your infrastructure, which will devoid the basis of information security in protecting the CIA trade. This is a statistics by IBM, which states that over 86% of home routers never have their password changed. It has always been like that. People usually just believe in the concept that because it's from the box, it's secure by default, which is totally wrong. This is the admin dashboard that is usually shown on different routers. This is from pfSense. We have this one and we have this one. All these have default credentials, and we are never forced as consumers to change these default credentials, which exposes our network in a way that becomes a problem. Let me give you a short simulation on how this particular router works, so you are able to see its core functions. So I take, for an example, a home setting, and I take for also that of the business setting. So this is the home setting. We see the router, it performs critical function here. So you see all of your devices are connected to it. It ensures that it disseminates information across these devices. This is for home router, your TV, your kids' phone, your kids' tablet, all their network are being simulated by the router. If you move to the business setting, you have your printer, you have your computer, your colleague's computer, the CCTV, all these other devices are also connected to the router. But because the router usually lives with default credential, it can, it can be easily spoofed. And because it can be easily spoofed, attacker can now have access to communicate to the router and make changes to these credentials and make changes to what you are communicating. So by default of its settings, it compromises the CIA trait that information should have. This is from the home setting and this is from the business settings. So it poses a lot of risk that we're exposed to. Non-technical people will not understand the gravity that this thing poses to them. So let's move a bit further. We try to look at some of the possible attacks that have been done if an attacker have access to your router. One, it redirects users to malicious web pages. So with your home router, you want to access your bank, you want to access your bank website. It spoof the DNS and redirect your request to his own vulnerable sites because you are non-technical, you wouldn't know the difference between the two, and you will be tempted to put your credential, assuming that it is your actual bank website. DDoS attack as part of large botnet. So once the brain, which is the router, has been attacked, it can spoof and it can send viruses to all related devices connected to it. And we have man-in-the-middle attack, which can perform data exfiltration. So if you are sending email to your colleague, the attacker can stand in the middle and make changes to this email, which devoid and which goes against non-repudiation as part of the authorization and the authentication mechanisms. And monitoring user behaviors with IoT devices. Of course, you have your kids at home, they are using your home routers. But because this router is being spoofed and is being attacked, this attacker can send adult content to your kit, which is uncontrollable, which might be uncontrollable by you, and it exposes kids to several dangers. As I'm speaking now, I did just a 30 seconds research. I will show you some real world statistics now. What I'm showing you is this is for my country, Sierra Leone. At the moment speaking, we have about 1,006 devices now in Sierra Leone that are up and running that uses default credentials. And these devices belongs to institutions, they belongs to homes, they belongs to government agencies. They are up and running now as I'm speaking to you. And we move a bit further, this is for Nigeria. We have 3,295 devices, and all of these devices are currently vulnerable to attacks because they are all using default credentials. And I'm sure these institutions that are using these routers are not aware. They've been using it for years without even having the urge or a way of making change to these credentials. I move a bit further to scan the region in which I include Ghana, Nigeria, and other countries. We see we have 23,000 devices that are currently up using default credential to provide internet access to consumers. This is for Ghana. I checked on the routers that have current login interface currently active. We have about 2,038 currently on that are providing access to users. And we asked the question, why does it persist? Why has this been happening over the years? It has always been like this. We try to examine the gap, and the gap is this. Manufacturers prioritize plug and play experience. They wouldn't want you to suffer that much. So they want, when they provide you the device, you just plug it and you have access to internet immediately without any overhead. They wouldn't want you to suffer that much. And user themselves, they always cherish the least resistance. They don't want anything extra. Once I buy my router or my modem, I want to have access to the internet and I'm safe. I don't want anything else. So because of this problem, we notice that now security becomes optional instead of fundamental, which has a big question mark because security has to be fundamental, not optional. We Give me a moment to look at this simulation as it helps you to understand better how devices are shipped directly. So when you buy your router from a start on box, it's new. This is your router, you've bought it, it's new. When you turn it on, it powers on, it loads its default credential automatically without them pushing you or making some asking users to put some cryptographic parameters. By default, they just load these default credentials and your device is connected to the internet automatically because user don't want that users may not want to push to make these credentials applicable. Then you get connected to the internet and you are good. You don't care anymore about what's next. I am good. I can use my internet anywhere I go. And suddenly there comes an attack because an attacker have already known the manufacturer of the device that you are using, and he knows that this manufacturer uses these default credentials, which are normally deterministic because the algorithms that are used to develop these credentials can be reversed engineered. So what is the solution? So I designed this solution, which I call the zero trust boot, by asking this question. What if security wasn't optional and we find a way to make it fundamental, required? So for any device, for you to have access to the internet, you are required to enter these credentials by default. If you don't enter this credential, you will not have access to the internet. And this is the solution, just a simulation of it, so it can help non-technical people to understand what the solution gravitates towards. So you have your internet, so you have your router by default, and you cannot have access to the internet even if you buy it new until when you connect to the internet, it asks you by default to set up your default admin username and password, and it's a must that you should do it. So this is different from the one that you see after you've connected to the internet. Because if you connect to the internet and you have that dashboard, it has already opened vectors of attacks. But this is from the very start. So once you enter some credentials, you enter your admin password, you set your Wi-Fi name password, you apply the changes, now you can get access to the internet. Then you are safe. Then you make the complexity hard enough for an attacker to be able to attack your system because now it is your credential. It is not depend on the credential of the manufacturer. So the technical implementation, what are the things that I use to design this solution? These I use QMO, which is a KVM hypervisor. I use OpenWrite, which I demonstrated it on an 86 architecture, and IP version 4 focused, but it's device and it's protocol agnostic. So it's also applicable for IP version 6. I use Ubuntu server and I use an isolated network just to simulate the entire environment to make it more clear for people to see how it works. So this is a visual implementation of the zero trust boot service that we are looking forward to. So now we have the internet, we have the OpenWrite, and we have the Ubuntu server, which I'm using. And with this simulation, we ensure that after a device has boot up, we created a cryptographic binding. So even if an attacker happens to reset your router, it forces them to enter these credentials. You cannot just reset your router and bypass this setup wizard. It does not work like that. After setting all of these credentials in place, then you can have access to the internet and you are sure that your kits, your network, and everything else you are using to simulate or to communicate within a network interface or a network setting are all protected. All your emails, all business data, all government information are all protected. So I give a visual comparison between what has been out there, which is the old vulnerable flow, and the new solution that I'm proposing. For the old one, once you power on your router, you have default credential active and you are good. For this new one, you're asked to make some mandatory required steps. And once you make those mandatory required steps, you have access to the internet and you are good to perform. your normal communication flow. I would like to do a demo of this entire architecture. It won't take.
Hello, Abdullah, can you hear me?
Yes, sir.
Can you try to summarize and
Yeah, sure,
finish?
sure.
Yeah.
Just to, I think
Just
the,
in 1 or 2 minutes
yes,
maximum.
yes, yes,
Yeah,
yes, yes, please.
let you.
Okay. So I will skip the demo because it will take a bit time, and we look at the benefits that this project will bring to Africa as a whole. For home users, you know that your kids are safe, you know that your information and everything you're doing and you're accessing on the internet are safe. And for businesses, you know that communication between corporate informations are safe and CIA trade is being protected. For national security, it's more essential for governance as well. And this is the phase that we are looking forward to. One is proof of concept, still trying to have it on the GUI um, platform. And after that, looking forward to engage with manufacturer for partnership agreement and see how we can able to have a workable version with less overhead cost. And then we move on to wide deployment and make it standard for router users in Africa as a whole. This is my presentation, and thank you so much for your attention.
Thanks a lot, Abdullah, for this theoretical and practical session and demo. So